Hello everyone, welcome back to my YouTube channel. This is Sandeep Kumar from Sri Venkateswara College of Engineering.
And today's topic is type of optical fibers based on refractive index and propagation of light and the material used. And coming to the introduction to optical fibers are thin strands of glass or plastic used of transmission data as a light signal. They play a crucial role in the telecommunication, internet services, and medical instruments. And the understanding of types of optical fibers is essential for selecting the right one for specific application. And this is the overview of reflective index. Is The reflective index determines how the light transfers through different materials, and the higher reflective index in the core allows the better light guidance. And the optical fibers are categorized based on the reflective index profiles which have influenced their performance. And here is the diagram of reflective index of the medium, water and the air. And above is the air is the incident angle is uh, uh, from the angle theta of incident, and the reflection is on the air is theta of reflection, and the refraction and the reflection is same on the media is water media is theta of reflection. And this is the type of reflection index profiles are there are two main type of refractive index profiles are step index and the graded index. And the step index fibers have sudden changes in the refractive index between the core and cladding, and the graded index fibers have gradually changes which reduces the model discipline and improves the performance. These are the some differences of step index and the graded index fibers are the refractive index of core is uniformly throughout the undergoes on abrupt changes at the core cladding boundaries. And the coming to the graded index, the refractive index of the core is made to vary gradually, such as maximum at the center of the core. And the diameter of the core is about 50 to 200 micrometer in the case of multi-mode fiber, and the 10 micrometer in the case of single mode fiber. And the diameter of the core is about 50 micrometer in the case of multi-mode fibers. And this is the graded index optical fibers. Graded index optic fiber have a core. Those refractive index decreases gradually from the center of the heads. And this design maximize the model, making the suitable for high speed data transmission. And the graded index fibers are widely used in the multi-mode applications such as local area networks, LANs. And the optical fiber is based another type is based on the propagation of light. Is optical fibers can be categorized by many how light propagates through them, single mode or multi mode. Single mode fibers allows only one mode light of propagation, enhancing single clarity and distance. And coming to the multi-mode fiber supports the multi light mode, which can be leads to differentiation over a long distance. And these are the diagrams, some diagrams of multi-mode optical fibers and the single mode fiber signal. And this is the diameter 50 to 62.5 micrometer core, and this is 9 micrometer core, and cladding are 125 micrometer. And coming to the single mode optical fibers have small core diameter, typically around 8 to 10 micrometer. They are designed for long distance communication, reducing the signal loss and destruction. This type of optical fibers is commonly used in the telecommunication and cable television. And coming to the multimode optical fibers. Multimode optical fibers have long core diameter, usually ranging from 50 to 62.5 micrometer. They are suitable for short distance due to increased model differentiation, and their optical fibers often used in the data centers and local area networks. And another type is material used in the optical fibers. This is the third type, and optical fibers are primarily made up of glass or plastic, each with unique properties. Glass optical fibers offer lower attenuation and are ideal for long distance communication, and plastic optical fibers are more flexible and easier to install but higher attenuation rates. And this is the structure of the optical fibers. Is center is the core, and after the core this is the cladding layer and the coating layer and the strength member and the outer jacket. These are some layers of the optical fibers are used in the material type. And coming to the glass optical fibers are made up of silica, which has excellent transmission property. They are highly resistant to environmental factors, making them durable and reliable. Glass fibers are commonly used in the telecommunication and high-speed data network. And coming to the plastic optical fibers, is the plastic optical fibers are made from polymer materials, making them lightweight and easy to handle. They have a longer core size, which allows for easy coupling with the light source, which suitable for short distance applications. Plastic optical fibers have higher signal attenuation than glass fiber. And these are some comparison of glass and plastic optical fibers. Our glass fibers provides the better performance for long distance transmission compared to plastic optical fibers, and the plastic optical fibers are often more affordable and easier to install, making them suitable for home networking. The choice between the glass and plastic fiber depends on the specific application and distance requirement. And these are some properties are tense strength and elastic modulus and elongation at break, specific gravity, maximum temperature of application, and the melting temperature and weight loss after 3 hours of boiling in or water, and to NaOH and HCl. These are some properties or comparison of glass and the plastic optical fibers. And coming to the application of optical fibers, are the optical fibers are widely used in telecommunication for high speed data transmission. They are also utilized in the medical instruments such as endoscopes for minimal invasive procedure, and the additional optical fibers are used in the industrial applications including the sensors and the lighting. And the advantages of the applications, advantages of optical fibers are optical fibers provides the high bandwidth, allowing for fast data transmission over the long distance, and they are immune for electromagnetic interference and ensuring signal integrity. Optical fibers are lightweight and occupy less space compared to the traditional copper cables. And these are the some disadvantages of optical fibers. The installation of optical fibers can be more complex and costlier than the copper cables. Glass optical fibers can be fragile and require careful handling during the installation. Needs for specialized equipment for connectors adds to the overall. And these are some future trends in the optical fiber technology. Are advanced in the fiber manufacturing techniques are expected to improve the performance and reduce the cost. Research in the ongoing development new materials enhancing light transmission durability. And these are the some key points summarized. As optical fibers can be categorized by the refractive index, propagation of light, and the materials used. Each type of optical fibers has specific application based on its unique characteristics, and understanding these difference is essential for effective communication system design. And this is the conclusion for the optical fibers. Is understanding the types of optical fibers helps in selecting the best option for your needs, and each type has advantages and disadvantages based on the reflective index, light propagation, and the material. Selecting the right optical fibers has a significantly impact performance and the reliability in the communication system. And this is the video on types of optical fibers is based on reflective index and material used and the mode of reflection. And thank you for watching.